Hi everyone, so let's talk about the path sum tree. So you're given a root of a binary tree and then enter the target. So you have to return a number of paths where the sum of the value along the path equal to the target sum. So in this case, it's pretty straightforward, but the problem is how do you actually code this one? So again, if you start from the 10, right? Starting from the 10, and then what is the path for the 10? So you will say 5, and then you 5, then you will split what? You will split 3 and 2, right? And then for the 10, you will split to what? 5, 5 and 3. So you have 2. So this is 5, 5 and 2, right? 10, 10, 5, and 10, 3. Okay. Negative 3, right? And then 5 will have 3 and 2 for children. And then 3 will have what? 3 will have 3 and negative 2 for the children. And then 2 will have what? 1. And then negative 3 have what? 11, positive 11. So you just have to traverse every single one of the possible combination of path equal to what? Equal to target sum. If you cannot find it, then basically what? Basically you need to try out your what? Your children. So you're starting from 5 and negative 3, and then doing the same logic, right? You'll try to find out another path, and then with the target sum, right? So in this question, I'm going to use the DFS. There's a solution using the hash map, using the prefix sum. And in this solution, in the prefix sum solution, I don't understand, and I would like to understand, but I don't understand. But in this question, I'm going to use DFS. And DFS basically is pretty straightforward. So I'm going to just code, and then you will be able to follow along. So again, I need a couple function. It's going to call DFS print null. I'm going to call null and then import it. So again, if the root is what is equal to null, this is the base case. You have to return 0, right? So at first, I'm going to traverse my root, right? So in n, I'm gonna say n for path sum equal to sorry. Path sum is not the DFS. So DFS, right? I'm passing the root and passing the target, right? So this is my traversal, right? I traverse every single possible combination of possible path for the target sum. But what if you cannot find out there's a path equal to a target sum, right? You need to change your root, right? Change your root to a children. So if you want to change your root to a children, you need to use the path sum. So I'm going to put left equal to what? Path sum without left, target sum. Again, for the right, equal to path sum without right, equal to target sum, right? So it's changing your root, right? And everything else, just find out how many possible paths to the answer, right? So again, for the DFS, if the root is actually equal to what? It's actually equal to null, you return 0, right? Right. So how do I traverse? How do I traverse the tree? I'm going to say DFS, and then I will say nota left, right? And then comma, and then target sum will just every single time would decrement. I mean, not decrement, subtract by the what? Nota left, right? Every single time. And this is not a root. Again, I made a mistake. And once again, if you have left, you need to have a right, right? And the problem is what you need to return int. So in this case, I'm saying int sum equal to 0. And then this is the path for the left, and this is path for the right, right? But the problem is I still haven't incremented my sum, right? So the problem is what? If I decrement my target sum, and then at some point, right, you will definitely find out the target sum is actually equal to not out, right? So for example, 5. So n minus 5 is what? Quickly draw the diagram. So n minus 5, this is going to be 3, right? 3 minus 2, this is going to be 1. So if 1 equal to 1, right? This is target sum. This is not val, right? If target sum is equal to not val, okay, sum is equal to not val, you will increment your sum, right? And then at the end, you will just return sum. Alright, so I hope I don't make mistake, but whatever. Let me submit. Alright, so let's talk about time and space. So in this case, the time is going to be unsquared. Why? For every single tree, right? Big tree, you need to traverse your root, traverse your left and right, and then if the current big tree is not working, you need to create another subtree. You need to create another subtree, and then this is gonna be I'm gonna get rid of this. And then for the subtree, you need to traverse again for the root, and then left and right, root, left and right, and then again you will definitely traverse on your right as well, right? So how many times? This is gonna be unsquared time for every single node. Be honest, right? And once again, like for the time, this is unsquared, and then for the space, right? For the space, it look like constant, but be honest, for every single tree, you need to create a sum, right? Variable sum. So this is all of them, right? You need to keep adding, and then when you want to add to the value, and then basically like sum is equal to 0 if the path is not possible, right? But if the sum is possible to find out the path is equal to a target sum, so you will have to return the sum, right? So this is all of them. You will create n times for the subtree. So this is a solution, and for the hash map solution, it's going to be called prefix sum solution. So again, I don't understand this solution. This is because you do have to say current sum minus k, and then you need to keep updating your k. And this is a diagram, and this is a solution for the LeetCode, and I don't understand, and I wish I could understand, but I don't understand. But if you do understand, you probably can leave a comment below, and I will see you later. So if you feel helpful, subscribe, like, and then I will see you later. Bye.